Very good morning. Welcome to the fourth session. So here we are going to discuss the major global missions of different space agencies like NASA, ESA or JAXA is there. Different agencies, what are the major space missions we are going to discuss in this class. Go ahead. First mission is Global Astrometric Interferometer for Astrophysics, GAIA. What it is about? It is a space observatory by European Space Agency ESA. It is launched in 2013 and have a lifetime till 2025. What is one speciality of this? So objective of this is to create most accurate 3D map of Milky Way galaxy and beyond. What it does is it will have observatories, it will observe the temperature changes, it will observe the motion movement of all the billion stars in the Milky Way, and it will create a map and details of all these stars. So this is done by European Space Agency. Now why is it in news recently? Because it observed something like star quakes event. What is this event? It is a huge cosmic tsunami that can even alter the shape of stars. Secondly, it has spotted a black hole phenomenon called Poheli. Poheli means black hole will have absorbed so much of things that it started acting like a source of unending creation. Something like a metaphor it is. So this kind of phenomenon that has been first observed by this space observatory by European Space Agency. So one thing you have to note here is, till now we have been doing this space mission by ISRO. ISRO missions you have to study in much detail. So we have been using these screenshots by directly taken from the ISRO website, brochure of that mission and all. Here you don't need to go into so much of the details. You only have to keep your knowledge base on limited number of things. What are these limited number of things? Who launched this program and what is the main objective of the program? Then if there is some very peculiar thing about this program, add that into it. Then what is the reason of developments regarding that? So we will limit only our knowledge to this much of that. Now each and every detail, which launch vehicle is there, these kind of details we will not come across. Go ahead. So the second program is, this is quite famous one, that is James Webb Space Telescope. In which agency launched this? It is a combined mission of NASA, European Space Agency and CSA, that is Canadian Space Agency. Which range of electromagnetic spectrum we are discussing or we are observing this satellite? It is in the infrared telescope, majorly infrared region is being observed. 6.5 meter means what? 6.5 meter mirror means diameter of this mirror will be used for this observation will be 6.5 meters. It will study every phase of the universe in our history. From Big Bang to so far, whatever the evolution that is going on in the universe, what is the different kind of stars that is already there or what is the stars that is evolving around, all these aspects will be studied by this mission. Recently it has observed Tarantula Nebula images, that is images of a nebula that has been captured. What is nebula? Before stars formation, there was a huge collection of gas clouds like that. That clouds is called nebula. Recently some images, like very colorful images you might have seen in the news, that is from James Webb telescope and all. Where this telescope is being launched? This is a predecessor of what? Very famous space observatory, that is Hubble Space Telescope. This is not predecessor. Hubble Space Telescope is the predecessor of James Webb Space Telescope. Now Hubble was a Earth-bound satellite. That means it was rotating around the Earth. Where this James Webb Telescope is being launched? It is placed at the Lagrange point 2. We have discussed that Aditya L1 Mission is placed at Lagrange point 1. It will be somewhere here. This James Webb Telescope is being launched or placed at Lagrange point 2. What is specialty of Lagrange point? Resultant gravitational force between two celestial system, it is defined. Two systems, Earth and Sun. Resultant gravitational force will be equal to centripetal force that is needed enough to keep this XYZ satellite in its position. When Earth is moving, this will automatically move along with this. That is the Lagrange point. How many Lagrange point will be there for a two body system? Total 5 Lagrange points will be there. Okay, we have discussed in the Aditya L1 class detailing of this. Go ahead. Next one is the DART mission. What is DART mission? Double asteroid redirection test. This is done by NASA itself. This is the first ever space mission to demonstrate asteroid deflection by kinetic impactor. So we've selected an asteroid and we will sending XYZ into this asteroid, and we are trying to divert the direction of this. Why we are doing this? Because Earth may be in line of so many asteroids or other cosmic particles that can impact the heat on Earth in future. So if something like that is coming, we need capability technologies to divert it or to deflect it. So this technology demonstration is done on 2 different asteroids is selected, Didymos and Dimorphos. Didymos is little bigger asteroid, while Dimorphos is a smaller asteroid that is rotating around it. So our satellite will go and hit it and we collect the data of this. Then this data will be used for analysis and all this. So this is DART mission. Clear? Go ahead. Now we have lofty technology. We discussed in the previous class itself. Moon, Mars and Earth, what is the major difference? Mars doesn't have a liquid core. Due to it doesn't have a liquid core means it doesn't have an active magnetic field shield around it. Now it doesn't have an active magnetic shield around means what? All the solar storms that is coming from the sun directly hit the atmosphere of the Mars. Now if solar storm is directly hitting the atmosphere, this atmosphere will be wiped out of the Mars. Atmosphere is wiped out means Mars is having a very thin atmosphere. Now if we are going for soft landing in Mars, usually what we does is, if something is doing soft landing on Earth, this satellite will be moving at a very high speed velocity. We need to decelerate this XYZ satellite into a very manageable velocity so that you can go and soft land it. So if there is atmosphere, you can do it very easily by using the drag force in the atmosphere. But since Mars doesn't has this much of a thick atmosphere, it will give more complexities to it. So this has been solved, or a technological mission on this regard is lofty mission. Lower Earth orbit flight test of an inflatable decelerator. It is using similar technology. There will be a huge balloon-like structure which will act as a parachute. All this will be going at hypersonic speed also, and this can decelerate the XYZ satellite into comparable ranges. Currently, this is being tested on the Earth. Later, it will be placed on some XYZ Mars mission. Objective is to get the soft landing on the Mars itself. Go ahead. Hypersonic inflatable aerodynamic decelerator. HIAD is the technology name for this XYZ. Go ahead. Artemis mission. What is one speciality of Artemis mission? You told that like woman is being sent into it, so gender equality, colored person is being sent into it. So these are all part of it. But the most major striking feature of Artemis mission is we have Apollo mission, all these programs of taking man or XYZ human to moon. So what speciality of Artemis mission is, this is a very long-term mission. It is started with a very long-term mission. What is this long-term mission? Using moon as a base for larger space exploration. That is, if we have to go to Mars, first you go to moon, then from there you will plan XYZ to the Mars. So making this base is the larger objective of Artemis mission. So in the first program by 2024, you will be sending one woman and other astronaut into moon under this program. Now what is other speciality of this? Where it will be sent? It will be sent into south pole of the moon. That is another speciality of this. Who is taking up these initiatives? It is a NASA initiative itself. Go ahead, rest of the details you can read from this, pause the video and go through this XYZ. Go ahead. Now there is an Artemis Code signed in parallel to this. What is Artemis Code? That is signed between this much of countries. India is currently not part of it, led by USA, and other countries like Australia, France, Mexico, Romania, Ukraine, all these are part of it. What exactly the idea is? United for peaceful exploration of deep space. We have seen SpaceX and so many other OneWeb, all these countries are actively getting engaged in this space exploration, space programs. So there should be some kind of standards, some kind of XYZ measures to be taken so that this space remain open access for all. So these kind of measures have been envisaged by this Artemis Code mission. Go ahead. Now Parker solar probe. What is this? We have learned about Aditya L1 mission. It was about, we are placing an XYZ satellite in the Lagrange 1 point, then we are observing the sun. Where does this Lagrange point come? Here is the sun, here is the earth. If the total distance is 100%, at 1% of this distance is the Lagrange point 1. There we are placing this Aditya L1 and we are observing the sun. Parker probe is a probe by NASA. What is the peculiar characteristics of this is traveling to the sun, and this will travel nearest possible distance. It will travel and give us the observations of the sun. And observation is what all it will be studying. All we are studying told in the last class, the same phenomenon will be studying. Something like why this solar sport is happening, sunspot is happening, why this plasma sun solar flare or cosmal mass ejection is happening, why coronal heating is happening, all this will be studied by this XY solar probe, Parker solar probe by NASA. Go ahead, rest of the details you can go through this XY slide. Go ahead, it will be arriving at sun by 2024. It's written something like this. Go ahead. HelioSupreme and Muse mission. This is only important is these are two missions for studying sun itself. This is by NASA itself. NASA mission to study sun itself. HelioSupreme mission means it is a constellation of 9 spacecraft that will capture first multi-scale XYZ magnetic and other measurements will be done. There will be a constellation of 9 satellites to study the sun. Muse mission means scientists understand forces deriving why heating of the sun's corona is happening. All this observation will be done by the Muse mission. All basics remain the same, only you have to keep in mind is the XYZ name of it. Then this is an XYZ mission by NASA. Go ahead. Now we have few moon programs that is being coming up. First one is Danuri. Danuri is a lunar mission of South Korea's moon mission. It is launched to the moon on August 2022, August 5, 2022. It will study the surface and do all the planning XYZ of surface. Important thing is Danuri is a lunar mission of South Korea. Similarly, another country that is showing so much interest is UAE is having its own Mars program recently. It is having its own lunar program also. This lunar program is having different components like Hakuto R mission lander that will land the XYZ in the moon, and there will be a moon Rashid rover that will go into the moon surface and do the collect and experiments and all. And this Hakuto is a Japanese name. Why this Japanese name come here? Because how ISRO is developing moon XYZ rover, all these technologies, we are completely indigenous. India is completely developing its rover, lander, orbiter, everything. Why UAE is doing? UAE is outsourcing this to some private organization, and this is a private company based in Japan which will specialize on landers in moon. So this company will be providing the technology to UAE. So that's why it's having a Japanese name, Hakuto R mission. Go ahead. So these are some areas like craters in the moon and all. You can have a look at it. Don't need too much of going into details. Go ahead. So ExoMars mission 2022. What is it? ExoMars mission is a astrobiology mission, mainly to check whether life was there on Mars or not. Who has done this? ESA has done this. Now it's a very famous payload is trace gas orbiter. Trace gas orbiter means it will look for any life related type of gas is there. Mostly what will be it is looking at? It will be looking at the methane. Methane has carbon and hydrogen. Hydrocarbon is there is huge chance life can be a part of it. So ExoMars 2022 mission, ESA mission look for life in Mars. Trace gas orbiter is the XYZ part of important part of it. Go ahead. Very interesting mission. Spectrographic investigation of nebula gas, SING mission. What is one peculiar thing that is so important to this mission? This is the first time a space collaboration is happening between India and China. And how this came into existence? This is exactly SING initiative. It's a UN-led initiative. And this UN purpose of this is China is building its China's Tiangong space station. For this space station, there is need for a payload. So UN is conducting an open competition like event for designing this payload. So in this UN initiative, India is also participating, which eventually will go into Chinese space station. So one way or the other, for the first time in history, India and China is having some kind of space level collaboration. That's why it is quite famous. You have to keep in mind the name. Spectrographic investigation of nebula gas. SING is the short form. Go ahead. Now we have some of the asteroid missions. The first one is HelioSupreme Mission. Which country launched this? Japan launched it. To which asteroid? Ryugu asteroid. R-Y-U-G-U. Ryugu asteroid. And it is not just a mission to an asteroid. What specialty of this mission was? It got there, went into the asteroid, collected some samples and returned the samples to Earth on 2020. So it has done a complete cycle of this. Then these experiments will be done on this, studying the asteroids. Why we are so much interested in asteroids? Asteroids are said to be time capsules. Like how they formed at the form of solar system, they have remained like that for all these years. So what was the constituent of matters during that time? What was the XYZ phenomena? Everything will be captured in this asteroids. So studying all this, we are so much interested in asteroids. So this is HelioSupreme mission. Secondly, we have a NASA mission called very similar mission, OSIRIS-REx mission. OSIRIS-REx mission is by NASA. And to which asteroid it is? Bennu asteroid it was. Okay. Rest details you can read from here. It is also having the same features. It will also go there, then collect some samples and bring the samples to Earth. It is done all the first part. It is expected to reach Earth in this year itself. Now Lucy mission, what is it? It is a NASA probe by NASA itself. It's a NASA probe on 12-year journey to 10 different asteroids. And these asteroids are in different belts. Main asteroid belt and Jupiter Trojans are also a part of it. What exactly is Jupiter Trojans? That we will see in the next slide. Go ahead. This is Lucy mission. This is OSIRIS-REx mission. Both these are NASA mission to asteroids. Now, what exactly is asteroid? Where it is present? Asteroids are minor planets. They have size ranging from 530 kilometer diameter to 10 meters, very small diameter size of asteroids are there. Currently we have one, how much is this? 12 lakh something asteroids are already discovered under this process. We have already discovered this much of asteroids. There may be more also. So where these asteroids are? We have separation between planets are having. Terrestrial planets means Mercury, Venus, Earth and Mars. After that there is a gas giants are starting from Jupiter, Uranus, Neptune and all this. So between these two there is a huge gap, and this gap is filled by a long number of asteroid belt is called as, this is where the main asteroid belt it is called. Now what is Jupiter Trojans? We have discussed about Lagrange points, L1 point, L2 point in this. What exactly is Lagrange point? If something is kept at this point, it will have enough centrifugal or centripetal force to move along with the movement of this planet without supplying any other energy. So we know that Jupiter is one of the biggest satellites and it has huge gravity compared to Earth and other planets due to its huge mass. Now it may be having a very huge Lagrange point at its two areas. Now some asteroid that at some point of time get trapped into it means it will all, as Jupiter is moving, this asteroid will also move along with this. So at two points, at L3 and L4 points of this, not L3 and L4 and L5 points of Lagrange points of system of Jupiter and Sun, asteroids are trapped. The asteroid traps there are called Trojan asteroids or Jupiter Trojans. Good enough? Now Jupiter is having too much of magnetic gravity that it start pulling this asteroid, it start altering the orbit of these asteroids. But these asteroids never get collided, they will go along with the Jupiter for infinity. Yeah, go ahead. Not just Jupiter, any other satellite theoretically can have this Trojan asteroids along with them. But Jupiter is too big, that's why it is having, it is in the range also, that's why it is having so much of Trojans. Go ahead. Now we have radio thermoelectric generators, RTGs. What we have to learn here is mainly this technology, where it is used and basics of the technology. That much only you have to learn. What is thermoelectric means? What is generator means? Electricity is produced. Function of generator is to produce electricity from some other forces. Thermoelectric means it will be using the temperature difference between two surfaces for XYZ purposes. Now thermoelectric generator means this temperature differential will be used for generating electricity. How this will be used? There will be some transducer material that is capable of directly converting temperature difference into electrical energy. Now radioisotope thermoelectric generator means this temperature difference will be created by nuclear fission or fusion. Nuclear fission of active radioisotopes. So we are using some nuclear fission, then creating a temperature difference, then this temperature difference is directly converted into electricity. Main important point is where this is used. This is used in long distance spacecraft programs of especially NASA programs. And mostly the satellites, where they are getting energy from? They are getting energy from solar panels. Solar panels, but issue is they have a limited lifetime. We have like Voyager satellites from 1970s, it is still going on. So this limited, it has a limited lifetime. This will limit the life of the XYZ. But if a nuclear technology is being used, it can have an extended lifetime. And this is one of the most reliable technologies also. So far it has a very high success rate. So this is application is what you need to keep in mind. It is mostly used in space level applications. Okay. So that's all. We have broadly covered all the important space programs of NASA, ESA and some other countries like JAXA and South Korea mission and UAE Luna missions. So in the next class, what we'll be doing? We'll doing the astronomical observations, astronomical observatories and recent developments regarding that. So that will comprehensively cover the space XYZ space sector programs. That's all. Thank you so much.